It's like I don't care about nothing, man. Yeah. Oh,
What's going on, home skillets? Coach Carr here. I am going to be your teacher. Now, this is going to be an interesting year. This might even be the only time you get to see my face without a mask. But I don't want to make the intro too long, so we just have to be like The Rock.
Focus!
And let's get to it.
Okay, so the beginning of this note packet is some vocab that we might need. Now, I don't want you to have to watch me actually write it down, so I'll do a little bit of movie magic. Ooh, it magically appeared.
Right.
So now, beginning should be review. So mean is our average. So the sum of all entries over the number of entries. The mode is the value that's represented the most. Not every data set is going to have a mode. So, and changing just one number can change the mode dramatically. So this is something that is resistant to outliers. That's something that you'll want to know. A median, it's the middle value, and that is also resistant to outliers. So this is something that's going to be used probably the most for us in the beginning. Range is the difference between the largest and smallest value of a data distribution. So if you don't remember what difference is, that means that we're subtracting. Quantitative data has a value or numerical measurement for which operations such as addition or averaging make sense. Then qualitative data, it describes an individual by placing the individual into a category or group. An example could be male or female. Next, we got the population data. This is the data that from every individual of interest, so everything. Sample data is the data from only some of the individuals of interest, so it's not everybody when you're using sample data. Parameter, numerical measure that describes an aspect of a population. A statistic is a numerical measure that describes an aspect of a sample. So page 2 deals with the different levels of measurement. First one is the nominal level of measurement. This applies to data that consists of names, labels, or categories. There is no implied criteria by which the data can be ordered from smallest to largest. Ordinal level of measurement applies to data that can be arranged in order. However, differences between data values either cannot be determined or are meaningless. Next is interval levels of measurement. This applies to data that can be arranged in order. In addition, differences between data values are meaningful. Then the last one on here for levels of measurement is ratio level of measurement. Applies to data that can be arranged in order. In addition, both differences between data values and ratios of data values are meaningful. This data has a true zero. The last thing on this page 2 is you need to know what makes a good graph. And what makes a good graph is titles, labels, and equal intervals. So the picture I have on there has titles, labels, and equal intervals. So this is actually a picture from Marshall from How I Met Your Mother.
This is a pie chart describing my favorite bars. And this is a bar graph describing my favorite pies.
Okay, so the next page is telling you about dot plots. Dot plots, or a dot chart or a strip plot, include all values from the data set, with one dot for each occurrence and observed value from the set. The pros for this, it's great for small sets of data. You should use it when discussing shape, center, or spread. And we'll be going over the different spreads later. So farther down on this page, something that you want to know is, here's just a visual example. So these dots represent the different data that's in there and how many of that certain amount there is. And another thing to know is the cons. So you don't use a dot plot for large sets of data. Histogram or box plots will deal with large data sets more efficiently. So if you can imagine having like hundreds of dots, you would not want to use this because it would not be very efficient. And on the next page, we have our histograms. So it subdivides data into intervals, which are called bins, and use rectangles, usually columns, to show the frequency of observation in each interval. The choice of the size of the intervals may vary. The pros for it is it's great for large data sets. You use it for continuous and quantitative data. So I gave you an example on that same page. So one thing that you want to remember with histograms is the histograms are going to touch. So that is something that you want to know when you're dealing with histograms. Another thing to know is its con. It says that you can't see specific values with this histogram. So for example, in this picture, let's say we know that the ratings for psych on this graph, the one that had the most votes was between 4 and 5. Well, we don't know exactly how many chose 4, how many chose 5. But we have a general idea that that's the most popular number that was voted for him. So the next thing to go over is the different terms to describe histograms. The first one listed, it says mound-shaped symmetrical. This term refers to a histogram in which both sides are for the most part the same when folded down the middle. So if I were to basically fold this paper in half, it would look the exact same on each side of the histogram. The next one is uniform or rectangular. These terms refer to a histogram in which every class has equal frequency. So you'll notice that they're not all exactly the same, but they're very close. So since they're all very close to being the same, we call it uniform or rectangular. So they don't have to be exactly the same, just very close to being the same.
We are same, but different, but still same.
Okay, so now the last two on that same page is we have skewed left or skewed right. This refers to a histogram in which one tail is stretched out longer than the other. The direction of the skewness is on the side of the longer tail. So this one's skewed left because it trails off to the left. This one is skewed right because it trails off to the right. Now, the one under it, it says bimodal. This refers to a histogram in which the two classes with the largest frequencies are separated by at least one class. The top two frequencies of these classes may have slightly different values. This type of situation sometimes indicate that we are sampling from two different populations. So you'll notice that there is two peaks that are higher than the others, but they're in two different, so since they're in two different spots, that lets us know that is bimodal. Okay, so the next thing we're looking at is a sample problem with a histogram and doing scales. So this is ones where you're actually going to draw the histogram and see which one makes the most sense for what they're asking. it's saying represent this data using histograms. So remember the histograms, they're going to be touching each other for each of those bars. For histogram 1, use a vertical scale of 5 million per unit starting from 0. For histogram 2, use a vertical scale of 1 million per unit starting from 60 million. And which histogram would you use if you were the manager of Fast Growing Inc. who wants to convince people that the company grows fast? Well, I did both of those, so I'll show you those right now. So the one that you are seeing right now is for the one where they said to start at 0 and go up by 5s. So if you notice with this, I put my months on the bottom, my sales on the left, and I make sure to have a title for it, like any good graph is supposed to. So with these, you can see that they are pretty close together. It looks pretty uniform. So the next one I'm going to show you is the one when you start at 60 and go up by 1s. So if you need to pause it so you can see what this looks like, feel free. So the second one that they wanted us to look at and make was the one where it starts at 0 and goes, then skips to 60 and goes up by 1s. So you notice that you have this little like zigzag, almost looks like a lightning bolt. That's the symbol you do if you're going to skip to a number. So we skipped to 60, that's why we had that symbol. So in this one, you notice that it's the same data as the one before, but this one looks very different, and it looks like we're growing a lot more rapidly. So if we're trying to grow more rapidly, or show that like that question asks, this would probably be the one that we want to use. So if you need to look at either one of these, just pause it on the video. So now looking back at the question we had, it was saying if you want to convince people that the company is growing fast, the one that we would want to use is histogram 2. So again, if you need to look at what they look like, you can go back and pause the video. The next one says, which would you use if you're a manager of Stable Income Inc., which is supposed to be the main competitor of Fast Growing, who wants to diminish the success of the competing company? So if you're trying to make it look to them like they are not making a lot of money, you want to use the first one that we saw. The reason being, since they were all a little bit more uniform, it does not look like they're actually growing that fast. The next one, how would you present the data if you were an independent observer who wants to represent the information in the most accurate way? So if you're trying to be the most accurate, you want to be able to see everything. So the easiest way to see everything is if you are going by 1s. So the one that goes by 1s was the second histogram. Then the last question on there says, what term would you use to describe this histogram? So the histogram that we just talked about was the second one. The second one, when we look at it, has a tail going more towards the left. So the tail tells us which skew it is. So this one would be skewed left.
Okay, so that's the end of this video. I hope you found it very informative. Now I'm going to try to be like a true YouTuber and tell you to like, subscribe, and ring that notification bell, whatever they call it. But I think the most important thing here is I am now able to cross something off my to-do list. So we made our first video of the year. More to come. Have a good rest of the day.